Hello everyone. Last video we were discussing about velocity time graph. In this video we will continue our discussion. So in last video we have discussed that when the car is traveling with a uniform velocity, how the velocity time graph we will it will be and how we will calculate the magnitude of displacement in that case. Now in this video we will discuss when the velocity is not uniform. As you can see in this graph, here that car was traveling with a uniform velocity of 40 km per hour. But here, the what tabular data I have shown here, here we are considering the velocity of the car at a regular instance over time. Every after 5 seconds we have measured, we have recorded the velocity of the car. It is in meter per second and it has converted into kilometer per hour. So here, if you can see, as time is increasing, time is progressing by every 5 seconds, then the corresponding velocity, if you observe that velocity, it is increasing, the velocity is not constant. Same thing if you plot graphically, when time is 0, when the velocity is 0, for the time 5, velocity is 9, for 10 it is 18, for 15 it is 27, for 20 it is 36, for 25 it is 45, and for 30 it is 54. And as you can observe, on the x-axis there is the time and the y-axis there is the velocity. But as time is increasing, the velocity of the object or the velocity of that car, it is increasing, right? So here velocity is directly proportional to the time. As time is increasing, velocity is increasing. Even though we have given name to this graph is uniformly accelerated motion with increasing velocity, we have said. Then why we have said here uniformly accelerated motion? What is the reason? Here you can see as time is increasing, velocity is increasing. It may be in meter per second or kilometer per hour, but as time is increasing, velocity is increasing. So what is the basic definition for uniform acceleration is, for uniform acceleration, velocity changes by equal amounts in equal intervals of time. Mainly for what we have said for uniform velocity, whenever displacement changes by equal amounts in equal interval of time, then we will call that velocity as a uniform velocity. Here, for uniform acceleration, what we are saying, velocity changes are of equal amount or equal magnitude in equal interval of time. More clarification, we will get it through this graph. Let us consider one time interval here. The time interval is dt, and for that time interval dt, this is the corresponding change in velocity. Line AB or height of the line AB or the line red color, it shows the change in velocity when time has changed from 0 second to 10 seconds. This is for first time interval. Now again for the second time interval dt, which is same, which is 10 seconds only. For here it is 20, here it is 10, 20 minus 10, 10. So for 10 seconds again, for the next second time interval, again if you observe the change in velocity ED, it is same. So if I calculate the height of this line and height of this line, both the heights are same, both the distances are same. So here what we are observing is the velocities change, the change in velocity for the particular time interval. It is for time interval 1. Similarly, for time interval 2 also, if I calculate, the ratio or that magnitude will remain constant. The value of this dv will remain constant. So such kind of acceleration we will call as uniform acceleration. Here velocity it is increasing, but the thing is, if I calculate the slope of this line, the slope of this line is nothing but change in velocity divided by time. That is acceleration or slope of this line. The slope of this line is constant. So here acceleration is constant, but velocity is increasing. As acceleration is constant, we will call this acceleration as uniform acceleration or uniformly accelerated motion. And here velocity is increasing. Now, even though the car travels with uniform velocity or uniformly accelerated motion, the basic thumb rule will be the remain same, that the area under the curve or area under the line, it will give us the magnitude of the displacement. So area under the curve, under this velocity, this is the actually velocity time graph. This is the time axis and this is the velocity time graph. The area between that, it will give us the magnitude of the displacement as we have discussed in earlier video. So area under the velocity time graph is equal to distance or magnitude of the displacement moved by the car in a given time interval. So for particular time interval t1 and t2, or time t2 minus t1, in that time, if I want to calculate the magnitude of the displacement, I need to calculate the area under this line. So how we will calculate it, we will discuss in next video. Thank you.